Hello and a good day, everyone. Today we are here from Group 4 from Eng3002-9, and today we are here to talk about our engineering application that we have decided using the Euler's method. Okay. Through WhatsApp and a lot of resources and sources that we have discussed through the WhatsApp group and previously, we have decided to use an application that is called, as you can see in the screen, the application of Newton's law of cooling in the manufacturing line. So in the WhatsApp group, we actually discussed that to split up our task based on four parts. Firstly is introduction, will be done by Kevin, and then second will be Zaf. The second is the engineering problem will be talked about by Zafi, and then the calculation will be talked about myself, and then the last comparison and conclusion will talk about Moga. But before that, I forgot to explain. I forgot to introduce myself. My name is Kitrash Alangis Aslam. My metric number is 211948. And then next, Kevin, introduce yourself.
Okay, my name is Kevin Santana Anthony, and my matrix number is 211491.
My name is Muhammad Zafiq, and my matrix number is 192006.
Hello, my name is Morganesh Anandakivishwaran, and my meeting number is 213018.
Okay, so finally, introduce yourself. Okay, so now the introduction will be presented by Kevin. Kevin.
Okay, thank you, Kirti. Okay, I'll just go through the introduction. This application is used to fix a problem with the packaging process while handling canned foods. In the thermal process, the food product is sterilized in addition to being cooked, and a thermal shock is created to completely predate germs that could harm the product. Food is packed hermetically, sealed containers, and is subjected to heat treatment. In food processes, heat transfer is a key element in controlling temperature. In this case, the canning process is used for food preservation. Canning is a common technique for food preservation and commercial sterilization. This process destroys microorganisms and enzymes that harms the food. When a can of food ends in its process in the autoclave, immediately goes to the packing area. However, when it enters the packaging area, it cannot be handled for its packaging because it has an inadequate temperature for handling, being the problem to solve located in the area of packaging, which is linked to the maintenance area. The importance of finding a numerical value with respect to the time that should remain in the cooling tub for subsequent handling for its packaging. Hence, the heat transfer rate is determined by Newton's cooling law that represents the overall effect of convection. Therefore, Newton's law of cooling is used in order to solve this problem. Newton's law of cooling states that rate of heat exchange between an object and its surroundings is proportional to the difference in temperature between the object and the surroundings. The heat transfer is carried out by different modes. Conduction occurs when there is temperature gradient in a solid or fluid stationary medium. Convection is the temperature gradient between a surface and a moving fluid. Thermal radiation occurs between two surfaces in the absence of a medium. The type heat transfer mode used for this application is convection. So yeah, that's all from me. Next.
Now, by the way, I forgot to tell that this is actually the partial report. So there are actually certain things that we actually have to change later on. But this is for the time being. This is what we have discussed and done by Kevin. So I suppose we can agree that we have to later on improve the wordings later on, so we can improve the introduction, right? Yeah, I hope everyone agree with that. Yes, I think.
Yeah. Yes.
Zafiq and Moga, do you agree with that? We have to improve more.
Yeah, I agree.
Yes, I agree.
Okay, next we'll move to our engineering problem.
All right. So for the engineering problems, so as explained as explained earlier, a food manufacturing company involved in the production of canned sardine wants to solve the problem of the packaging process while handling the canned food. So we have to find the time required for the can during its cooling process to obtain a temperature for 40 degrees Celsius for the packaging. And so for this, the methodology used is the Newton's law of cooling for heat transfer, which states that the rate of heat exchange between an object and its environment is proportional to the temperature difference between the object and the environment. So as shown, the differential equation for this is given by dx over dt equals to negative k x minus x naught. So where the t is the time while x is the temperature of the can at any time. X naught is the surrounding temperature, which is constant and given to be 35 degrees Celsius, which is also the temperature of the water in the cooling tube based on the problems given. And the K is a positive constant that depends on the area and the nature of body under consideration. So to find K, we define the value of the convection heat transfer mode constant with a can temperature of 60 degrees Celsius. And then with this information, we can use the Euler's method and analytical method to find the temperature of the canned sardine after 2 minutes with using a step size of 0.2 minutes. So that's all for the engineering problem.
Yeah. Okay. Thank you, Zafiq. I hope everyone understands the engineering problem. Hopefully. Okay.
Yes, we understand.
Okay, thank you, Muga. Okay, let's move on to the calculation. This one I will explain. First of all, from the equation, we can understand that there are we have to find the constant of K actually. And then later on, we have to find the constant C as you see in the picture. Okay, first step is that we use the separable differential equation in the first order of differential equation. If you separate it, then you can get C this over 1 over x minus x naught dx equals to negative k dt, and then we integrate that. After we integrate, we will get this form is a ln x minus x naught and then negative kt plus c, which is another constant we receive doing this kind of equations. After that, we exponent both sides, and then we finally end up having this part like modulus x minus x naught equals to c x, this is a constant, exponent negative kt. Okay, and then we have to know that the temperature of the object, which is the canned sardine, is greater than the temperature of surrounding. Okay, so the temperature of surrounding has been fixed at 35 degrees Celsius, and the temperature of the object is initial temperature is 75 degrees Celsius, which is in the question if I'm not mistaken. Later on, we move to this part of dx dt equals to c exponent negative 80 plus 35. We get when you substitute the initial temperature, the surrounding temperature, sorry. And then using the T naught, which is T at time 0, which is we get a 75 degree, which means it's the initial temperature of the canned sardine. We will get a constant for C, and then we define the value of the convection heat transfer mode constant with a temperature of 60 degrees Celsius, which we will try to find the value of K, which is 0.235. So the final equation we receive is 40 x equation in terms of t, 40 exponent power of negative 0.235 t plus 35 degrees. So that's the equation. And now I want to share my Excel here. Okay, here is how we did. I did the Euler's method. Can everyone see the Euler's method?
Yes.
Yes, clearly.
Okay, thank you. Okay. Did you understand the calculation before this? Hopefully everyone okay with that also.
Yes, we understand.
Okay, thank you. I proceed now. So now we have the differential equation. We have the differential equation dx over dt equals to negative 0.25 is the k, bracket the x minus the initial temperature is the 35. And then we use this equation of Euler's method, and then we find the value of temperature at a given time for 2 minutes using the Euler's method. So the Euler's method at the 2 minutes using the increment of 0.2 in the way substituting this value, you will get the 57.046 degrees. And then for the analytical method, the analytical method is a different way of you try to integrate first, and then we substitute the value of t accordingly, like 0.2, 0.4, which is like using a manual way. And then for that, analytical method, it produces an exact value. Exact value means it's more accurate compared to the Euler's method in a way. So from using it, I get that the second minute, we get the value of the temperature for the can is 60 degrees Celsius. Okay. Next is about the comparison part, and it will be presented by Morgan. I hope you guys understand the calculation part. That's all. Noga.
Okay, thank you for your explanation on the calculation, Prithviraj. Now I'm going to compare and make a conclusion on the calculation. So to find the percentage of error, we need to subtract the exact value with the value we calculated using Euler's method, and then divide it with exact value. After that, we multiply the answer with 100 to get the percentage of error. As we can see from the table, at second minute, the temperature we calculated using Euler's method is 57.046 degrees Celsius. Whereas using the analytical method, I've received the exact value of temperature, which is 60 degrees Celsius. As the time increases, the percentage of error also increases. At second minute, we received the percentage of error, which is 4.923%, as shown in the Excel. So, as we can see in the graph, the blue line is represented by Euler's method, and the orange line is represented by the analytical method. As we can see, as the time increased, the blue line deviated a little bit from the orange line. So that's all. I'm going to use the conclusion. So in conclusion, both Euler's method and analytical method can be used to calculate the temperature of canned sardine after 2 minutes using the differential equation given below, which is dx over dt equal to negative k inside bracket x minus x over bracket. And the next one, the comparison I already explained just now. So I move on to the next one. So despite having small percentage of error, it is recommended to use the analytical method to calculate the temperature of the can, as it is more precise and accurate compared to the value found using Euler's method. This is because in food production, even small change in temperature might affect the food quality, which in this case is canned sardine. Food packaging using heat treatment is important to preserve the food for a long period of time and also be safe to be eaten. Hence, we think the best way to produce canned sardines with desired temperature accurately is by using the analytical method. So that's all from me. Thank you.
Okay. I think everyone has done the part I explained well. I think I like the conclusion by Morgan and also the calculation done in the percentage of error. The graph looks nice, as you can see. The graph looks nice. It seems that using the increment of 0.2 is still accurate line. The way to get the right percentage, at least to minimize the percentage of error. So I hope our topic is actually, I want just to repeat our topic, which is about the application of Newton's law of cooling in the manufacturing line, which is the food production law for sardine, canned sardine. So I hope everyone agrees with this topic, and then later on we'll do more about fixing our mistakes law. Okay, so everyone agree with this topic, hopefully.
Yes, yes, we agree. I agree with our topic.
Yeah,
Does anyone have any other opinion to improve, maybe in the conclusion or maybe introduction, maybe, or in the engineering problem, if they want to add anything extra? In my opinion, I think introduction we need extra points lah. Extra points to explain further more about the production line. I think anyone has any other addition maybe can give? Any?
I don't know. What about Taufik? Do you have any suggestion?
Sorry for if my connection is a little bit bad. I think maybe for the engineering problem part, I might want to add a little bit more lah, to make it more clear the process and some more information, because I think there's a little bit of information need to stated there.
Okay. Thank you, Zafir. Kevin, do you have anything to add?
No, it's just that we have to, work on the introduction. It's here and there, so you have to, rearrange it in a correct way so that the readers can understand more clearly.
Okay, I think that's correct. I think that's how we're going to improve and progress the report. Okay, so this is actually a partial report. So later on, we'll finish a report in a week or so. So thank you, everyone. That's all from us. Okay, thank you.
So much.
Thank you.
Thank you, everyone.